Our lecture today will be on the subject of number theory. Number theory, we told during our introduction class, it's oldest field of mathematics. It's always was great thing for brain exercises, for entertainment, but it was absolutely useless. But everything changed in 1976 when three young American mathematicians developed revolutionary new crypto system based on number theory. So this week we have two class in the number theory, and next week we will use this number theory to explain a new crypto system and how apply number theory in modern crypto system. So let's start by a simple fact. And you know it, but let's recall. So if we want to divide integer a, so a is integer, let's denote it by z, and if b it's positive integer, always we can divide a by b, and we can represent it as e equals b times q plus r. And r, this is remainder, and remainder must be between 0, more or equal 0, and it must be less than b. So if remainder is equal 0, it means that b divides a. So if remainder is 0, we can say that b divides a, and we can denote it like this. Let's give simple example. 7 divided by 2, we can represent it as 2 times 3 plus 1. Okay, it looks simple, this representation of integer, and it's, in fact, it's simple, but we will use it over and over. So pay attention here. A, it's integer, negative or positive. B, it's positive integer. And R, it's number between 0 and b. And as for Q, it's quotient, and it can be negative or it can be positive number, or it can be 0. Okay. Next, what we need today is to define congruence. And A, we can say that A congruent B modulo n if and only, so if and only n divides b minus a. So this expression, it's called congruence, and A congruent B modulo n. So it means n divides B minus A. Okay. My first question. What if I will say instead n divides B minus A? Instead if I will say that n divides A minus B. Are they equivalent? Can I say that instead n divides B minus A? To write here that A congruent B modulo n, it's equivalent, n divides A minus B. What do you think? Is there any difference?
Yes, the sign will be different, so we may need the model.
Yes, sign, it will be different, Salome. Sign will be different if we will divide B minus A, if we will divide by n, and A minus B, if we will divide by n, absolutely, you are absolutely right. We will get opposite numbers. But here, we are not dividing, but we just indicated fact that n divides B minus A. So if n divides B minus A,
there will be no difference. So
absolutely, you are absolutely right. N divides B minus A, it's absolutely equivalent that n divides A minus B. So there are no difference. We can say n divides B minus A and n divides A minus B. There are no difference. Okay. Next question. Can we say that A congruent modulo B modulo n equivalent that A equals B plus K times n, where K is integer. K it's integer. It can be positive or it can be negative. My question, are these two expressions equivalent? So A congruent B modulo n equivalent A equals B plus K times n. K is some integer. The idea, I highly recommend to take paper and pen and write down everything. Any idea? Are they equivalent or not? And what it means equivalent? Equivalent, it means that from the left side implies right side and vice versa. From the right side, we can conclude left side.
I think it's false.
Okay, Georgi. So, but you have advantage to disprove, Georgi. You have advantage, and we told many times that disprove, when you want to disprove, you have advantage. To disprove, they are sufficient to give one counterexample. If you will give one counterexample, you will disprove that it's not true. They are not equivalent. And try to give. And if we need to prove that they are equivalent, we can prove it in general. But if you want to disprove it, they are absolutely enough for one counterexample. One counterexample you can assign particular values to A, B, N, and if there will be not possible to find such K, it will be disproved.
Yes.
So, Georgi, think about this counterexample. Any other idea? What do you think? What do you think? I can give an example of congruence. For instance, we can write down 12 congruent. 12 congruent, for example, 7 modulo 5. It's true. 12 congruent, 12 congruent 7 modulo 5, because 12 minus 7 is 5 and 5 divides 5. Also, another example, we can say 10 congruent 3, or I will write here 13 congruent 3 mod 5. Also true, because 13 minus 3 is 10 and 5 divides 10. Okay, let's go back to our example. What do you think? True or false?
I think it's true, but I don't know how to prove it.
Okay, so by intuition, Salome, by intuition, you think that it's true. Your inner conviction is that it's true. But we
Yes.
know inner conviction, it's not good proof. And I think it's not hard to prove that it's true, because A congruent B modulo N, it's equivalent. It's equivalent that by definition, it's equivalent then N divides A minus B. And N divides A minus B, I can write down as A minus B equals K times N. Do you agree with me? For example, what is that?
Yes, yes.
How we know that 3 divides 6? How we know? Because we can find integer 2 such that 2 times 3 is 6. So A minus B, N divides A minus B, it's A minus B equals K times N. And now, I think all of you will agree if I will write down here that A equals B plus K times N. Any questions so far?
No.
Okay. So, and I can write down as example. For example, 13 congruent 3 modulo 5. We can write down it as 13.
What does module mean in this case? I'm kind of confused.
Okay, David, modulo, it's remainder. So if I will write down 7 mod
okay.
5, it equals
7 with a remainder of 5.
Yes, it equals 2. It equals 2. So 7 modulo 5, it equals 2. 7 modulo 5, it's just remainder. But congruence, we defined it like this. Look here, congruence, we defined like this. A congruent B modulo n if and only n divides B minus A. So, of course, congruence is related with remainder, and we will see it very soon, but they are not the same. So it's just the notion, these 3 horizontal lines, is just the notion that A congruent B modulo n. But A modulo B more modulo n equals R. It means that if we will divide A by n, our remainder, it will be R. Is it clear, David?
Yes.
Okay. So I can give example. For example, 13 congruent 3 modulo 5, 13 congruent 3 modulo 5, we can write down it as 13 equals 3 times 13 equals 3 plus 2 times 5. So K, in this case, K is 2. This is K. One particular example. Okay, any questions so far? Okay, now I have one more question. So we proved that A congruent B modulo n, it's equivalent that A we can represent it as A equals B plus K times n. Now, my next question is A congruent B modulo n and another expression A mod n equals B mod n. My question is, are these two expressions equivalent? So this expression and expression below, are they equivalent or not? I can give example, and I can take the same example, 13 congruent 3 modulo 5, and we can check on this example. What is 13 modulo 5?
3.
It's 3. Absolutely, it's 3. What is 3 mod 5?
3.
It's 3 again. So, according to this example, this is true, but question is, Is it true for any A, B, and N?
I don't think so.
So, Georgi, do you think it's true always?
No.
I think it's true.
Oh, Georgi, you have advantage to give counter example. If you will find counter example, if you will find A integer, B integer,
Yeah, I get it.
B integer, and N is positive integer, and N is greater than 1. N is greater than 1. It's by definition, because if N equals 1, it's meaningless, because when A we will divide by N by 1, any number can be divided by 1. So if you will find 3 numbers, integer B, integer A, and integer greater than 1, and it will not be true, we can say that you disproved it very successfully. Can you give example?
No.
So no counter example. But how can we prove that this is true? How can we prove it? This is a question. How can
We can represent A as Pn plus R and B as Qn plus R, and then we can rewrite A minus B.
Okay, just a minute, Salome. I
And
will
it
write.
will be-
So you think I should represent from here? Do you mean from here? Yes.
Yes, and we can represent A as
A.
Pn plus R.
Okay, I will do it. So A equals B plus K times N. Okay, Salome, I did what you told. Next.
I said not B, but any other letter.
Here, not B. Salome,
Any other letter.
Salome, look.
No, not B, like P, for example.
Yes.
Salome, from here for the first expression. So what we need to prove? Let's clarify what we need to prove. What we need to prove? We need to prove that they are equivalent, these two expressions. And they are equivalent, it means that A congruent B modulo N implies it implies A modulo N equals B modulo N, and then vice versa. A modulo N equals B modulo N implies A congruent B modulo N. So let's suppose I will help you to start our reasoning, our argument. So let's suppose that A congruent B modulo N. Then continue, please. Salome, continue.
My way was easier, I think. I didn't understand.
From here, we can write down that A equals B plus K times N. Any idea?
I don't know this way, but I proved it by using other things. First expression that was A is equal to B mod N is when we wrote the first expression. not this one. The thing that we have to prove.
This one.
No, not this one. A equal to B plus K times N.
This one.
That we have written. Yes. So I
Okay.
proved in a different way. I choose that there will be only 3 possible ways. B is equal to N, B is greater than A, and B is less than A. Yes.
Yes. Yes, it's always true. B
Yes.
less than N, B equals N, or B. Oh, very interesting. Yes. Or B is greater than N. Okay.
So in first way, when B is equal to N, it means that the B mod N will be B. So in this way, the K will be 0 and the A will be B.
So A equals B plus Kn. So
Yes.
first case 1.
If
B
is equal to N.
equals N.
Yes.
Okay.
In up, A is equal to B mod N, or where we have written there. We know that this expression will be a 0. Yes. A will be 0 in this case. Since if B is equal to N, A will be 0.
So if we have A, in this case we have A congruent N mod N.
Yes. So it will be 0. A will be 0.
It's not necessary N to be 0. It's not
Why?
necessary. It's not necessary. A may be not 0 because it just means that N divides A minus N. And A can be 0, but at the same time, A can be, for example, 5 times N.
But if we have N mod N, it is 0, since the remainder will be 0.
Yes, remainder will be 0.
So A will be 0 in this case, since A is a remainder in this case. Yes.
Salome, look.
No, it's not.
A
Why?
congruent N modulo N. It just
Yes.
means that N divides A minus N. N divides A minus N. And
It's
A,
not an equal sign.
yes, it's not equal sign. Yes, right. And it just means that N divides A minus N. Then it's not necessary that A should be 0. A can be, for example, 5 times N. 5 times N minus N, it's 4 times N, and N divides 4 times N.
Oh, so A can be a different. Okay. I thought
Yes, A
different
can
way.
be different number.
Okay.
Okay, Salome,
Then
but it was very good idea. Okay, any other idea?
I have an idea, but I think you did not understand my idea.
Oh. Salome, maybe you will write it and send me. And so here, how can we prove it? So A.
I have an idea.
Okay, Irakli.
So we have equation A equals B plus K times N, right?
Yes, it's given.
So if both sides are equal, we can take mod N of the both numbers. So we can write A mod N equals B plus K times N mod N, right?
Yes, but but we need to prove it directly. We did not prove it yet.
So if numbers are equal, so their reminders are equal. So I'm saying this.
Okay. So from here, you think we can write down that it implies A mod N. equals B plus Kn mod n. Do you mean it?
Yes, yes.
Okay.
Then we can write that Kn is the mod n of Kn is 0. So we can just clear parentheses and write it equals B mod n.
Yes, exactly. It's very close. It's very close, but we missed some properties of modulo, and these properties we will see very soon. But it's very close. But you use properties that B plus Kn mod it equals B mod n plus Kn mod n. Yes?
Yes.
Yes, and we will see it soon. It's true, but we will see it soon.
I have a solution, I think.
Okay, Georgi.
I think it's what Salome was trying to say. For example, A is equal to
A
P,
equals to
Pn, P.
P.
Yeah.
Okay.
Pn
Pn
plus R.
plus R. Okay.
B is equal to Qn plus R.
Oh, I think it's a very good idea. Qn
N.
plus R.
Yeah. And if we subtract these two, we get
Oh, very good idea. A very good idea, Georgi. It's fantastic idea. But you proved converse. You proved that if remainder, now you proved, I think you proved very successfully that if this is true,
yeah.
if this is true, because here what you told, it means that when we divided n by r, so it means that when a we divided by n, and when b we divided by n, remainders are the same.
Right.
Got it right?
Yes.
Okay, very good, very good. So you suppose that this right side is true, and since A modulo n and B modulo n, they are equal, you write it very successfully, very good. You represent it, it's very good. As A equals integer times n plus r, and B equals some integer q times n plus r. And you used in both expressions r because you supposed that these remainders are equal. Very good. It's very good proof. It's very good proof. It's very good proof of converse. When it's given that. So Georgi proved very successfully that A mod n equals B mod n. It implies A congruent B mod n. Very successful, because from this expression A mod n equals B mod n, we wrote down these two expressions. Then we will subtract it, and if we will subtract these two expressions, we have A minus B equals n times P minus Q. And P minus Q, it's integer, and it means that n divides A minus B. And n divides A minus B, it's the same as A is congruent B modulo n. Very good, Georgi, very good solution. Okay. So we proved this, and also we can prove in the same way, and I hope all of you will prove it, that if A congruent B modulo N, then these remainders also are the same. Okay. Please try to prove it and email me as homework. Okay. Now we need to discuss some properties of congruence. So, given A congruent C modulo N, and given that B congruent C modulo N, not C but D here, different number. Now, what do you think, true or false, that A plus B
I just saw some pretty lady at fucking Stop and Shop.
congruent
Wait, I think I know.
C plus D modulo N? Any idea? True or false? So it's given A congruent C modulo N, B congruent D modulo N, the same modulo. And my question is, true or false? A plus B,
True.
A plus B, congruent C plus D. In other words, we can add two congruents.
Yes, it's true, I think.
So Andros thinks it's true. Any other idea or counterexample? It's hard to find counterexample because it's true. And also A minus B congruent C minus D mod N. In fact, they are the same properties because in algebra, it does not matter what is sign. They are almost the same. And what we will use more often, A times B equals A times B equals C times D mod N. Okay, let's prove this last congruence, and congruence above, they are more easy to prove. So, given A congruent C modulo N and B congruent D modulo N, and we need to prove this congruence. So from here, A congruent C modulo N, we can write down that A equals C plus S times N. S is some integer. Do you agree?
Yes.
Yes.
And also we can write down that B equals D plus S times N. Do you agree?
Yes.
All of you agree?
Same as? Is it appropriate to use your same as?
Oh, very good note from Andro. Yes, we should use here different letter because we don't know that they are the same or not. So I should use different letter here. It will be integer, but it will be different integer. Okay, now let's multiply it. A times B equals C plus S times N D plus Tn, and it equals C times D plus Ctn plus S times Nd and plus Stn square. Now, from here, I can factor out n, and we have Cd equals not equals, but plus Cd plus n times, and it does not matter what will be in parentheses. What does matter? In parentheses, we have integer. And this integer is S times T plus S times D plus Stn. So this is integer. And it's integer. It means that n divides AB minus CD. And it means that it's true. Any questions? And next property, and this next property, it implies from this congruence, and this property is that A times M congruent C times M modulo N. And how it implies from this last congruence? It implies because I can write this expression 2 times and multiply. For example, A congruent B modulo N, and instead, not B but C here, and below, instead this expression, I will write the same, A congruent C modulo N. And now if I will use this property and if I will multiply these congruences, we have A square congruent C square modulo N. And I can do it any times. And if we want to prove it, to get solid proof, we can use induction to prove for any M. So this property, it implies from this property. Okay, now please, I would like to ask you again to write down these formulas because now we will check these formulas to to test how it works for particular numbers. Did you write down it? Okay, I will
Wait.
here.
In the first case, there is missing n, or a times b is that's called c times d mod, and there's written nothing.
Yes,
Not,
yes, Salome, you are absolutely right. Here I missed n. Do you mean here? Yes, here.
Yes, yes.
Okay, thank you. Here we have, of course, here we have n. Okay. Okay, so also I will write down here that A congruent B modulo N, it's equivalent that A modulo N equals B modulo N. Okay, now I will write down expression and you should say it's true or false. And my expression is that A times B. So I want to recall that it's given and from here I want to write down the following: A times B equivalent A mod N times B mod N mod N. So question is, are they equivalent or not? So I claim that this property, I rewrite it in this view. True or false? Look very carefully. And second one, So let's say again what I claim. I claim that when it's given, what I marked in red shape, and we proved that A times B each congruent C times D modulo N. I claim that this expression and this expression are the same. So instead C here, I have A mod N. Instead C, I have here A mod N. And instead B, and instead D, I have B mod N.
Right.
It's true, I think.
Okay, okay, but let's first answer this question. My question, it's different. If I will write down A congruent B modulo N, is it equivalent of expression of congruence A equivalent A mod N? Are they equivalent or not?
Yes, they are, because the minus sign doesn't matter.
Yes, they are absolutely equivalent. They are absolutely equivalent. It's called symmetric property of congruence, that A congruent B mod N, it's equivalent to B congruent N A mod N. Because what it means? It means that N divides A minus B, and we also noticed a few minutes ago that N divides A minus B and N divides B minus A, they are the same. So they are absolutely equivalent. And if they are equivalent, look now, we have here A equivalent, A congruent C mod N. And from here, I can write down from here that C, it's congruent A mod N. So I use these notations. So I agree they are congruent. Now let's check this in numbers and it will be more clear. For example, we have 26. I will write down here 26 congruent to mod 4. True or false?
True.
55 congruent 3 mod 4.
False. Oh, true, yeah.
It's true also. So now I want now to use this formula to find what is remainder of product 55 times 26 divided by 4. So I want to find 55 times 26 modulo 4. And to find it, I will write down it. It equals 55 modulo 4 times 26 modulo 4 and mod 4. So what is idea? Idea is that if I want to find remainder of product 55 times 26 modulo 4, I can find remainder when I divided 55 by 4.
Okay, I'm still confused as to what module 4 means. Is it just 55 plus 4? What does 55 with a remainder of 4 mean?
It means that if we divide 55 by 4, we get a remainder.
Oh, the remainder
That's
that
it.
you get when 50. Oh, right. Just like in
Yeah.
code. Yeah, okay. Hold on, let me try this.
We will do it now, David. Look, it equals. And now, what is 55 mod 4?
3.
It's 3. It's 3. So we have here 3 times 2, because 26 modulo 4, it's 2. Mod 4. And it's clear that this is 2. So instead to multiply 55 by 26, then divide by 4 and find remainder. Instead we can find remainder of when 55 we dividing by 4, then 26 dividing by 4, multiply these reminders, and then find 3 times 2 modulo 4. Okay. Also, what we need, now we will use this formula. I mean, this formula, but I have here mistake. Here must be M, not 2, but M. Now, for example, now we need to find remainder 144 in the power 4 mod 713. So we need to find this remainder. To find this remainder, we know that in the power 4, we can represent as 40 square and square. Okay, so now I will use it and I will write down 144 mod 713. I will represent it as 144 square mod 713. Any questions? This is in square.
No, it's clear.
Okay. Now, I will represent it as 144 square mod.
Oh.
So I'm using now this formula. So idea of this formula is that instead to find a remainder when 144 in the power to the power 4 we dividing by 713, first we will find remainder when 144 square we divided by 713, and then we will square it. So now we need to square 144. Can you help me to square it by calculator? 144 square, and I have here this number. This is
It is 20,736.
Okay, thank you. Now, we need now to find this remainder. And we can use ordinary calculator. And I think it's easy for you to find it. We need by calculator just divide this number by 713. And then what we got, we will take from there only whole number. And then this number we will multiply by 713 and then subtract from this 20,736. Is it clear for everyone? I will show on small numbers. For example, we need to find remainder 23 mod 5. How can we use calculator? In the calculator, we will divide 23, we will divide by 5, and we will get 4 times 6. And now I will not pay attention to this 6. And I need only this whole number 4. Then I will multiply 5 by 4. It's 20. And then I will subtract 20 from the 23. And it's 3. The same here. We will divide it. We will get some number. Then this whole number.
It will be
Okay.
647.
600. Say again, Salome.
647.
47. And did you got this reminder?
Yes, yes, this reminder.
Check again, Salome. Check again. I will also do it. So we should divide 27, 3, 6 divided by 7, 1, 3. It's 29. And now 29. 29, we should multiply by 713, and now we should subtract it from 2736.
Oh, I thought it was written 2073. I didn't
No problem.
saw the 6.
So we got 59. We have this reminder 59, Salome. You can check again. So
yes, it's 9.
This number. So if we will divide 23, 6, if we will divide by 713, and we have here 29, whole number. Then this number we will divide by 29, and we will subtract it from 2736. And it equals 59. So now it's 59, and I should write 59 square mod 713. Now we need to square 59, and we have 3, 4, 8, 9, and mod and now it equals 6 to 9. So our properties, what is advantage of properties of this congruence? So we needed to find remainder when very big number 144 to the power 4 divided by 713, and instead we found a remainder when divided not 144 into the power 4, but to the power 2. And this is our final answer. We found that this is 6 to 9. So when you do this example, and to understand it, it's always good to do it in the ordinary calculator, However, it would be fine if you will write some short computer program to find this remainder. Any questions?
No.
Okay, in the next class, we will continue.
We'll have the quiz in the next class, right?
Yes, next class we have quizzes. And we will continue this topic. And
What
then,
chapter is this? Chapter 7?
yes, it's just a minute, I will see. No, it's chapter 8.4. And in the module, I will upload pages from book. You have your textbook, but despite it, now I will create module, as I remember, it's module 9. And in the module 9, I will upload page from this textbook for this topic.
So we skipped the chapter 7 and some sub-chapters from 6?
Yes, and now it's chapter 8.4. 8.4.
Okay.
We skipped it. It's about relations, and relations from my experience, it's not very interesting for students, and that's why I did not include it in the topic.
Okay.
Okay. See you on Friday.
Right.
Bye. Thanks for joining.
Goodbye.
Bye.
Goodbye.